folks. Welcome to
Vector calculus.
Alright folks, welcome back to the next lecture in vector calculus. Today we're going to find the equation of a plane given 3 points on the plane. Let's go ahead and check out the problem. So here, to really get a good idea of what the equation of our plane is, we need a big picture. That's the moral of the story. You need a big picture for a big problem. So let's go ahead and do that, okay? So let's draw a huge plane over here. So I'm going to go ahead and draw a kind of big plane over here so you can kind of get a good picture of what's happening. So here's my plane, and let me just cut out these edges over here, and let's put down our 3 points. Okay, let's say one of our points is here, one of our points is here, and one of our points is here. Right, bottom line is we got 3 points. Now what are we going to do with these 3 points? Well, what we're going to do is we're going to make vectors, right? What's our end goal? Our end goal is to get the equation of the plane containing these 3 points. But remember, to get the equation of a plane, we need the equation or the components of the normal vector to this plane. And why is that? Well, remember that the normal vector to this plane, the components of that normal vector, let's call it A, B, and C, those components are going to be the same as the coefficients of the equation of our plane. Okay, so remember, if we have a plane and it has a normal vector with components A, B, and C, the coefficients of the equation of our plane will be A, B, and C. You see that? There's a very amazing, very neat symmetric relationship between the plane and its normal vector. And that relationship is that the components of the normal vector are the same as the coefficients of the plane. Okay, and so we can use that to our advantage, right? Because we have 3 points here. Using these 3 points, we can make 2 vectors. Here's one, here's another. Finding the cross product of these 2 vectors is going to give you the normal vector. And then finding the components of that normal vector is going to give you the coefficients of your plane. Okay? So how do we find that normal vector? How do we find that cross product if it's so important? Well, it's not too bad. Let's put down our 3 points, okay? So what's our first point? It's going to be 4, negative 1, negative 2. 4, negative 1, negative 2. It's going to be negative 5, 0, 3. Negative 5, not 3. And finally, it's going to be negative 2, 4, negative 1. Okay, so now what we can do is think about how we can start forming vectors, right? We want to get these 2 vectors. How do we get those 2 vectors? Well, it's pretty simple. Subtract the components, subtract the coordinates of these 2 points, you get a vector. All right, so 4 minus negative 5, that's 9. Negative 1 minus 0, negative 1. Negative 2 minus 3, negative 5. There you go, that's 1 vector. How about this vector? Well, same story. Subtract the coordinates, you get a vector. Negative 5 minus negative 2, that's going to be negative 3. 0 minus 4, that's going to be minus 4. 3 minus negative 1, that's going to be 4. Alright, so we've got our 2 vectors. What do we do with them? Well, to find the vector orthogonal to 2 vectors, you need a very specific operation called the cross product. And if you don't know where I got that from, just watch our 10 lectures on the cross product. Okay, so let's go ahead and compute this operation right here. First thing I'm going to do is find the cross product of our 2 vectors. What 2 vectors do we have? Well, hopefully you see that. My first vector is, let's call my first vector A. Or you know what? I don't want to confuse you. Let's call our first vector, I don't know, let's call it U. Let's call our first vector U. And it has components 9, negative 1, negative 5. Okay? And our second vector, let's call it W. Okay? And it has components of negative 3, negative 4, and 4. Okay, now let me just check whether the camera can actually see this, and thank gosh it can. Okay, so now what we're gonna do is just find the cross product of these 2 guys. So to find the cross product, remember we're gonna do some cofactor expansion here. So I hat, J hat, K hat. By the way, I'm going to go a bit fast on this calculation. If you don't know how I'm doing it, just check out our cofactor expansion video. Very simple, very nice. Okay. So 9, -1, -5, -3, -4, 4. And now let's do it. What's the cross product going to be? Well, it's going to be I hat times, well, what's it going to be? Well, check out the diagonals. -1 times 4, that's -4, minus -4 times -5, that's 20. Alright, so now we're going to subtract from I hat, we're going to subtract j hat. And what's j hat going to be? Well, j hat, check it out, is going to be 9 times 4, gives me a nice 36, minus -3, -5 gives me a nice 15. And finally, I'm left with plus k hat. Alright, so what's plus k hat? Well, check it out. We've got 9 times -4, that's going to give us -36, minus -3 times -1 is going to give me 3. And now I can just kind of simplify all of this mess, right? Let's come over here to the top so I can rewrite everything nicely. Okay, so I don't need that anymore. Okay, so what is my cross product going to be? Well, look at the bottom and hopefully you'll see my cross product will simply be I hat. What will I hat be? It's going to be -24 I hat. Okay, and then what's this? 21 j hat, minus 21 j hat. And finally, it's going to be minus 39 k hat. So, what can we deduce from this? Well, first and foremost, this is the normal vector, yes? This is the normal vector to the plane. These are the components of the normal vector, and so these will be the coefficients of our plane. So, our plane, the equation of our plane is simply going to be -24x minus 21y minus 39j, z, and finally we'll have our constant d. All of that is going to equal 0. But what is our constant d going to be? Well, to find out, we need to plug in one of these 3 points. Let's plug in -5, 0, and 3. Okay, so I'm going to plug in one of these points. Let's plug in this one. So I'm going to do -24 times -5. Okay, you know what? This calculation is better suited for the upper left corner. So we're going to have -24 times -5. So -24 times -5. Alright, minus 21 times 0. And finally, -39 times 3. And all of that, if you add it up, something plus d is 0. So 24 times 5 is 120. Alright, minus 21 times 0 is 0. 39 times 3, well, that's going to be what? I don't know that off the top of my head, so we got to do the math here. Alright, so that looks like 97, 117 actually. So we're going to have minus 117 plus d is 0. And so 3 plus d is 0. D is minus 3. And so what is the equation of our plane? It's minus 24x minus 21y minus 39z minus 3 is equal to 0. And that, ladies and gentlemen, is the equation of our plane. That's how you find the equation of a plane given 3 points. And that's it for this lecture of vector calculus. We'll check you out next time.
Embedded plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.